Morning, everyone. I'm going to be talking to you today about our project in which we're trying to assess how we can incorporate climate change into our spatial planning using Table Mountain National Park as an example. This project has been funded by the Table Mountain Fund, and we have a large number of collaborators who've been involved in this work. So I just want to say thank you to them up front for the huge effort that they've put into this project to date. So where did this project originate? So in sandparks, our parks are governed by what we call park management plans. And these plans detail where activities can occur within the national park. So things like tourism and recreation and rehabilitation, and specifically where spatially these activities can occur. So the planning team will make use of things like vegetation types, species distributions, and heritage assets and view sheds and so on, to develop what they call sensitivity layers. So highly sensitive areas you would, for example, not allow certain activities. But up to now, we have not considered the impact of climate change on sensitivity of particular areas. So the question was, how can we possibly include climate change when we think about sensitivity of particular areas in the national park? So that was the major objective of this project, which we split into a number of sub-objectives. We wanted to really understand the physical climate of the national park. We wanted to understand the vulnerability of species that occur in the national park. And then we wanted to see how these unique climates and species map spatially and what we can learn from that, and what management actions we could potentially implement to reduce vulnerability of species and sites. And then finally, to use the learning that we've generated through this project to create awareness for other protected areas of how they might do something similar. So just to give you an idea of the workflow of our project, our collaborator Jasper Slingsby has been working on a number of aspects relating to how we define the physical characteristics of the peninsula. So for example, microclimate data in combination with soils and fire history, to provide an estimate of different climate zones and unique habitats across the area of interest. We're also interested in, as I mentioned, species level vulnerabilities and where these vulnerable species occur in space and in relation to those physical spaces on the peninsula. Finally, we were interested in socioeconomic vulnerabilities like impacts on tourism and infrastructure, and we hope to combine all of this information to produce a climate sensitivity layer that can be used in park planning. Right, so to take a step back, climate has clearly been changing in the area. This is, for example, data from Cape Point. You can see both for minimum and maximum temperatures, there's been a really significant increase over the last 50 to 60 years, and that's showing no sign of stopping anytime soon. But we know that Cape Point is just one space, and that the peninsula is filled with different types of habitats. So how would species experience things if they were somewhere else on the peninsula? And so that's where Jasper's work comes in. He's been doing some fabulous work looking at microclimates using loggers. And you can see, for example, here he's mapped January mean maximum temperatures, and there's a massive difference on the flats compared to the peak on Table Mountain, where the average summer temperature is only 17 degrees at the peak, whereas it's 32 on the flats. And similarly for winter, very big differences in temperature experienced on different parts of the peninsula. Now, how to use this information is a bit of a developing field. You can see here that mapping climate zones can be divided into physical and species-based approaches, but there are a range of methods within each one. So we've developed a number of physical approaches to mapping the zones in Table Mountain Park. So the one that you can see here, we've combined temperature and rainfall information to produce 30 unique climate zones. However, the biological significance of these zones remains to be tested. And to do this, we required a database of the species that occur across the peninsula, and we need to know where they occur and which ones of them are vulnerable. And this sounds very straightforward. You just ask someone for the data. But sadly, it was not so straightforward. And we asked many people for the data, and we found that none of it matched up, and people had called species different things and put information in wrong columns and used all kinds of different methods to name their species. And Pat Holmes has done a phenomenal job in trying to update and collate a master species list for the area, assisted by Tony Ribello. And I'm not going to go into the details of what you need to do to get this right, but basically, if you want your data to have longevity, you need to think a little bit about how you collect and curate it, because otherwise it's easier to throw it out than to try and make it speak to a database where there are no key linking columns. On a positive side on this note, there have been a number of spin-offs, and Sandparks is in the process of doing an MOU with Sandy. And we also have a new project post available who's going to help us work on this for other parks. And this has really provided an example case study of what to do and what not to do, and new ways of going about things when we actually collect our information. So I think despite the trials and tribulations that Pat went through, there's a massive amount of positives and good learning that we can take from this. Right, so once you've got your species list, you need to think about how are your species vulnerable. So vulnerability in terms of climate change is defined as the nexus between where species are exposed to climate change, whether or not they are sensitive, and how easy it is for them to adapt to any changes that they are experiencing. So if you're exposed, sensitive, and you can't adapt, then you are vulnerable. So the IUCN has done a lot of work in this regard, and we have a project team member, Wendy Foden, who's actually the chair of the IUCN Climate Change Species Survival Commission Specialist Group. And so she's really been guiding us in how to apply this methodology. But basically, there are 5 key groups of traits that you might want to consider in terms of sensitivity to climate change, which can be unpacked for your species and area of interest. In terms of poor adaptive capacity, things like inability to disperse would make you have poor adaptive capacity. In terms of exposure, even if you don't have good climate models, you can think about what are the likely impacts from things like sea level rise, what types of temperature changes might you be worried about, precipitation changes, and so on. We haven't expressly modeled climate change, but what we are doing is taking the information on the unique climate zones and using that to combine with species habitat and dispersal likelihoods to get an idea of the types of climate change sensitivities that they are going to face. So this phase involves workshops with experts to get an idea of the type of traits of interest. So we conducted a workshop for reptiles and amphibians. Here you can see all of us thinking about what might make them sensitive and vulnerable to climate change in person with no masks on. Sadly, when it got to the plants and there were infinitely more plants and much more to fight about, we were left to do this on Microsoft Teams. There you can see us being very, very scientific. Once you have your list of traits that you're going to collect data for, you collect data for each and every species on your list, which for plants was a very, very long list. And Pat Holmes did this work for us when it came to plants. We had a student, Jack Harper, who looked at the reptile and amphibians. We also looked at which traits might be deal breakers in terms of some things. Yes, it might make you sensitive, but you could probably survive, whereas other things, if that happened, you would definitely not survive. And what we still need to do is combine the trait assessment with the spatial layers that Jasper has been producing. And then you can rank your species in terms of relative vulnerability. So this is still an ongoing process, as I mentioned, for plants. We have completed the process for reptiles and amphibians. So for example, here we have the 2 most vulnerable amphibians, the peninsular moss frog and the Table Mountain ghost frog. But what's really nice about the approach is that it helps us to identify why these species are vulnerable. So for example, with the reptiles and amphibians, common traits leading to high sensitivity were dependence on environmental cues and an inability to reproduce more than once annually. Whereas things hindering adaptive capacity were lacks of commensalism with humans. So species would be unable to move through human-modified landscapes, for example. And this helps us along the way to coming up with management solutions. So just to have a quick look in terms of amphibians, what we can do with this information, you can see here in Cape Point, there's a really high density of vulnerable species in the south, which all correspond with this yellow climate zone. And interestingly, that yellow climate zone only actually occurs here in the south of the park. The other yellow space is above the park near Table Bay. So it can give some insights into what one may and may not want to do in the face of this change. So getting on to management actions, we haven't actually workshopped this component yet, but we've thought about it a bit from a reptile and amphibian perspective. So there's a number of things you could do. You could divert footpaths from core areas, prioritize alien clearing in sensitive areas, restore microhabitats, or you could tailor your monitoring to the seasons and spaces that are deemed to be critically important. Then there are also more interventionist actions. So for example, you could create microhabitats. You might say, well, that's not something that we do. But in fact, it is. So we have stressed out penguins. They obviously face a number of other challenges as well, but we do create microhabitats for them to nest in. And what could we do something similar for other species? So for example, if a frog responds to a particular breeding cue and we know that a big flash flood is coming that could wash all of its eggs away and that would be it for that season, is there something that we could do to prevent that? So one needs to think a little bit laterally. In terms of enhancing species adaptive capacity, one can assess where roads or other infrastructure impact on key corridors. So we know from overseas they've made great use of species corridors. We can think about how to do this for plants as well in terms of preventing fence line impacts and so on. And then there's also assisted reintroduction to suitable microsites, which again, you might not think we do, but here we are planting silver trees. And yeah, we'd really welcome some ideas and practical examples of what's been trialed in other places. In the last component of our project, I mentioned that we looked at socioeconomic impacts. We just looked at weather impacts on tourism, and we also looked at infrastructure risk to floods, mudslides, fire, and storm surge. Unfortunately, you don't have time to go into the results, but you can see here some interesting patterns emerging in terms of tourists being impacted by weather. Unlike other parts of the country where you might see a drop-off in tourism when it gets too hot, we have no problems like that here in the Cape. The hotter it gets, the more tourists we get. Rain's a bit of a downer, but not so the southeaster. People will brave the southeaster to come and see penguins. So some kind of expected but interesting results in respect to weather. So finishing up, we need to map our species distributions in relation to those climate zones and see how we can use this to produce a sensitivity layer. We need to really fine-tune those management options, and I think that's going to be the exciting part where we can really start to experiment with what we can do. And then I think most importantly, this has got to be written up in a way that it can be used by other protected areas. A lot of stuff gets written by the international literature, but it hasn't been trialed. So this is really an exciting example of stuff that is being trialed. So thank you so much to TMF for bearing with us on this project, and yeah, I'll be keen to chat to you more.